subtopic is relationship between an interior angle and its corresponding exterior angle. So let me use the example. I have a three-sided polygon which is a triangle. So we have, in any polygon, the number of vertices equals number of interior angles. So I'm saying that number of vertices equals number of interior angles also equals number of exterior angles also equal number of sides. So whenever you're given that's the total number of vertices, we still have the total number of sides. Like this, we have 3 vertices, 1, 2, 3, and we have 3 sides, and we still have interior angle. See, look at the interior angle, maybe A, B, and C. We still have an exterior angle is formed if you extend one of the sides. So this is the exterior. This is the exterior to C. YE is the exterior to A. Y this is the exterior to B. So we have 3 exterior, 3 interior, 3 vertices, 3 sides. So there is a relationship connected. As you can see, this is a straight line. What do you notice? You form a linear pair, that's angle on a straight line. So what do you have to say here? We'll notice that if you sum the sum of the interior, that's any interior angle, plus the corresponding exterior angle must be equal to 180 degrees. Yes, based on angle on a straight line. So that's the relationship connecting interior and its corresponding exterior angle. We still solve questions on this. Let's know the foundation before we move to questions, real technical questions. So we're on number of non-intersecting triangles. Non-intersecting triangles. So let me just, okay. Non-intersecting triangle. So in any polygon, we can form triangle inside. Yes. And how do you do it? If we join vertices, that's non-adjacent vertex, like forming a diagonal. Once a diagonal is formed, triangle will be formed. So that's what we are going to do. We want to get a formula from the number of non-intersecting triangles in a polygon. So as you can see, we have 3-sided polygon. This is 3 sides. We have only one triangle, as you can see. We have one triangle because we have 3 sides. But looking at this, let's join vertex B and D. We now form 2 triangles. Yes, we have 2 triangles. So we have 4 sides. How many triangles? 2 non-intersecting triangles. So looking at this one, the last one, before we get a general formula for that, we have this. Remember, non-intersecting. So they will not intersect, because we can still join H to K, but it will intersect. This is okay. So that's it. We have how many triangles? 3. 1, 2, and 3. So since we have 5 sides, We have 5 sides. 5 sides. How many triangles? 3 triangles. So what do you notice here? You notice the difference. What's 3 minus 1? 2, right? 4 minus 2, 2. 5 minus 3, 2. So it's always constant. So how do you get number of intersecting? So generally, for n-sided polygon, we have n minus 2 non-intersecting triangles inside the polygon. So this is a very important formula. It will help us to get the sum of the interior angles of a polygon. So let's move to, okay, let's just solve the equation. First one, we ask find the number of non-intersecting triangles of the following polygon. So the first one, so octagon is that the number of sides is 8, which implies it will have 8 minus 2 non-intersecting triangles. So we have 6 non-intersecting triangles. While the second one, nonagon, is 9 sides. So it will have 9 minus 2, which is 7 non-intersecting triangles. And finally, decagon is 10 sides. So we have 10 minus 2, which is 8 non-intersecting triangles. So with that, let's look at some of the interior angles of a polygon. This will help us, the number of non-intersecting triangles. What I will do, let me just, okay. Let me copy this and paste once. So we are going to get a formula. So since we've gotten number of non-intersecting triangles, we can get the sum of the interior angles of these polygons. Yes, we're going to get a formula. So what do you notice? Here we have 3 sides. We have 1 non-intersecting triangle. Yes. But for here, we have 4 sides. And we have how many non-intersecting? 2. 2 triangles. We have 5 sides. We have 3 triangles. So if I want to get the sum of the interior angles, it's simple. So what do you know? What can you deduce from this? We can get the sum. This is 1 triangle. So the sum of the angles will now be number of non-intersecting triangles. That's 1 times 1, 8. Yes. Where 1 is the number of non-intersecting triangles. So what of this? We have 2. So 2, 1, this is 180. This is the second 180. So the sum of the interior angles will now be 2 times 180 degrees. Coming here, the sum of the interior angles is now 3 times 180 because we have 3 of them. 1, 2, 1, this is 1, this is 2, and this is 3. So from here, we can now deduce another formula. We now get a general formula. So generally, the sum of the interior angles of a polygon is equal to n minus 2. That is the number of non-intersecting triangle times 180. So this is a formula. This is a special formula for the sum of the interior angles of a polygon. So let's use it and solve, maybe let's solve the question. So they said find the sum of the interior angle of a nonagon. So that's the first question. So I can partition this. Let me partition it into 3 so that we solve fast. So the first one, number 1. A nonagon is a 9-sided polygon. So the sum of the interior angles is now equal to 9 minus 2 times 1/8, which is 7 times 1/8. So our answer is 0. That's 0. This is 6. Carry 5 plus 5. That's 1,260 degrees. So this is the sum of all the interior angles of this polygon. While the second one, they say the interior angle of a polygon are 1, 2, 3, 4, 5, 6. Find the value of x. So this is a technical question. So let me move this so that we'll have more space. So for the second one, as you can see, remember how many interior angles are here? 1, 2, 3, 4, 5, 6. Meaning that the number of sides is 6. I've told you earlier that the number of vertices is always equal to the number of interior angles, number of exterior angles, number of the vertices. So we are given 6 interior angles. We have 6-sided polygon. And they said we should find the value of x. So we now use a logic. Since we've known all the angles, we know that if you sum it, it must give us n minus 2 times 180, where n is 6. So I'm saying that if you add x plus 10 degrees plus x minus 20 degrees, we'll have plus 2x minus 10 plus x plus 40 plus 3x minus 10 plus 2x plus 30 must be equal to the sum, which is n. Our n is 6 minus 2 times 180. So sum this is equal to 10x. Summing the ones with x, 1, 2, 4, 5, 8, 10. So let's add the other. 10 minus 20 is minus 10. Minus 10 minus 10 is minus 20. Minus 20 plus 40 is plus 20. Plus 20 minus 10 is 10. And 10 plus 30 is 40. So that's it. Equal to 4 times 180 degrees. Because 6 minus 2 is that. So as you can see, 4 times 180 is 720. Right? Yes, 720. So this is 10x plus 4. Remember the degrees are gone. So what you have to say, 720 minus 40. So I have 10x equal to 720 minus that is 6. That should be 680. And finally, x is 680 divided by 10, which is 68. As I did 680 over 10, which is 68. So the x value is 68. So it's a technical question. So finally, the last one, they said the sum of the interior angles of a pentagon is 6x plus 6y. We're asked to find y in terms of x. Whenever you're asked to find y, something in terms of something, they're telling us to make y to stand alone. That move it to to the other side of the equation. Let it stand alone. You now move others to the other side. Depending, if you want it to be in left hand side, you keep it there while you move others to the right hand side. Or if you want it to be in the right hand side, you move others. That's the meaning. So we'll make it the subject of formula. That's the second way of saying, writing something in terms of the other thing is to make it the subject of formula. Just keep it in one side of the equation. So that's it. They told us this is a pentagon, and they gave us the sum. A pentagon, the sum is 5 minus 2 times 180. And also they gave us the sum as 6x plus 6y. Do you get the logic? They gave us the sum. We know the sum as n minus 2 times 180. But they still gave us the sum as 6x plus. So we equate it, forming an equation. So I have 5 minus 2 is 3. So I have 3 times 180 equals, in mathematics, to make our solution easier, I have 6x and I have 6y. We can bring out 6 and we'll have x plus 1. That's factorization. Factorization, just bring out a common term, maybe the HCF. Bring out what is common in both. You now write there. That's the meaning. That's what I did here. So that we can leave our answer to the simplest form possible. So let's create another slide so that we'll continue. The last, okay, we're left with 3 times 180. I normally use asterisk to differentiate it from x. 6 bracket x plus 1. So what do you notice? I can move my 6 to this side to be here. That's to dividing both sides by 6. So we're still on the right track. The next one, we can divide. 3 in 6 is 2. 2 in 180 is 90. But they told us to make y to stand alone. So y standing alone, y stands alone, yx moves. So we have 90 minus x. So that's it. That's our answer. We've made y the subject of formula, or we've written it in terms of x.